Hello everyone. Today we are going to present our paper exploring a sustainable building's impact on occupant mental health and cognitive function in a virtual environment. We are a group of researchers from University of Maryland. I am Ming Hu, and later on you will hear presentation from Professor Madeline Simon and Professor Edward Burnett.
Our research goals are to develop, test, and validate a data-driven neuroscience approach to assessing impacts of sustainable design features on occupant stress, behaviors, and attitudes. We employ a mindfulness framework where mindfulness is narrowly defined as a greater focus on the present moment through increased engagement with the built environment and activities occurring in it. We have two hypotheses. Number one, compared to conventional buildings, occupants will respond to sustainable buildings with higher engagement, particularly to the sustainable visual stimuli. Hence, sustainable buildings are associated with increased visual system engagement compared to conventional buildings. Second, compared to conventional buildings, occupants of sustainable buildings will exhibit modulated attentional focus and control processing.
The theoretic framework of this research is the combination of event-related potential, cognitive architecture theory, and cognitive load theory. The method we use is based on the simulated virtual environment. Essentially, what we did is to build two different virtual models, one for sustainable design, sustainable building, and the second is for conventional building. In the sustainable building model, we figured the flowing open space with access to daylight and views, and in the conventional buildings, we characterized the conventional building by compartmentalized spaces with artificial lighting and very little view. After we created those two virtual environments, one for sustainable, one for conventional, we immersed the test subjects, total 36 test subjects in those two different virtual environments. And at the same time, we outfit them, we have them all wear an EEG cap to monitor their brain activity in responding to the different virtual environment. For the tasks we have the subjects to do within the virtual environment, to allow the utilization of both continuous and event-related EEG, ERP analytic method, and that we have the test subjects first view a 5 minutes video continuous walk through the different environment, and then we have the test subjects view 45 still images which is extracted from this walkthrough, continuous walkthrough animation, so that we can collect the exact brain activity, brain response to the special events. The events are the different views, different design figures, such as the views and the daylight levels. And this viewing the still image take about another 15 minutes. So all together, we have test subjects being immersed in the each virtual environment for a total 25 minutes. And here is example video showing you how we register a recording brain activities while those test subjects walking through the virtual environment. And this is one of the sustainable environment. And you can see clearly some of the brain activity changes in this recording.
So here are the three tasks that Ming just described: the movie, the still images, and the immersive virtual reality. We've collected 36 participants in the first wave, for which we're presenting the data today, including the movie and still images. We have 16 additional participants that have the immersive virtual reality and also participate in the other conditions that we are nearly at the end of processing, but I don't have something to present about them right now. Okay, here are the results from the still images, or the event-related potentials, the ERPs. And the primary findings are, as listed in the box here, a increase in visual processing, we see at the back in the occipital regions, and decreased frontal, which would involve control regions, coordinated. And it's these two findings that we're using to make an inference about mindfulness, an increased focus on occipital or visual processing of the external environment, and decreased processing prefrontally, so further processing of information internally. So a primary way we can see that is here under amplitude, under time differences. In these heads you can see that blue, which represents there having been greater activity for conventional buildings, and red, which is greater activity for sustainable buildings, indicates that there is for sustainable buildings, a decrease in frontal, increase in occipital or visual. And you can see this black and white map is just black where it is not significant, white where it is. And that is the core finding that I'll show you some of the other measures indicate as well. These below here break this down into separable processes using alpha, theta, and delta oscillations, and we're able to understand a little better some of the specific component processes. Similarly, with functional connectivity, we can see in the theta band a decrease in the frontal where it's blue for sustainable, and an increase in occipital where it's red for sustainable. And so with functional connectivity is the communication between regions. So we see these different regions showing different patterns of activation for sustainable versus conventional, and the way in which they talk within region and between regions is also modulated by the building type. Okay, results are presented here for the continuous EEG during the movie segment. On the left side, you can see the amplitude results indicate increases in theta band activity for the sustainable building, including medial, frontal, central parietal, and occipital areas. Differences weren't observed in alpha or delta frequency bands. For the functional connectivity, significant modulations were observed for sustainable buildings. Delta and theta observed significant increases, and alpha we observed significant decreases. This is consistent with the idea of theta and delta as excitatory, increases in sustainable relative to conventional buildings, and alpha as inhibitory, producing decreases for the sustainable relative to the conventional buildings. The indication of these findings will be discussed as we go through.
This research is part of a larger project that seeks to further understand the psychological and cognitive impact of sustainable buildings. In the present study, we provide initial validation of combining EEG with event-related potentials. This sets the stage for planned extensions to virtual design approaches with the EEG, ERP in immersive virtual reality environments. We can discuss the contributions of this study at two levels. First, cognitive affective processing modulated by sustainable buildings, and second, validation of the research method.
Continue on the discussion and conclusion related to the cognitive load processing modulated by the different virtual environment. The present findings can be explained by the CLT, the cognitive load theory, which is consistent with the interpretation of a greater focus on the present environment and reduced internal mental processing. And so those two, if we put those two together, is the common mindfulness status people often refer to. And this interpretation is based on observed increased theta and delta activities and greater engagement of visual system and the corresponding decrease in frontal activities when we immerse the test subjects in the sustainable virtual environment. And such mindfulness is often associated with receptive attention and perceptual clarity. Also can be associated with reduction in workplace burnout, improvements in personal well-being and team and organizational performance, and overall the organization environment. So the idea of increased occupant mindfulness as a mechanism is consistent with the reports that occupants in the sustainable environment often feel stronger environmental satisfaction and support, positively associated with the job satisfaction and better job performance. 3 built environment variables views, light, and spatial arrangement were used to elicit brain activation and response in sustainable building compared to conventional buildings. This virtual design technology provides methods for detailed and systematic manipulation of environmental parameters such as views and spatial arrangement, which could be and would be prohibitively expensive to study in the real environment, in the real building. And also we will need to wait after the real building being completed and being built. Such method provides such virtual environmental design technology provides opportunities for designers and architects to change the design based on the neuroscience response to the preferable built environment, such as sustainable building, hence identifying the optimized design solution of the built environment. So we think this combination of using virtual environmental technology and EEG could be a different way for designer and architect to take on design in the future. And this concludes our presentation for today. And here is our team member, and we are open for questions.